Today's lesson is rate of change and slope. Our objectives today are to find rates of changes from tables and graphs and to find the slope. So today's more or less going to be how to look at a graph with a line and figure out its slope by looking at the graph, and then also by doing the mathematical part of it with just looking at two coordinate points. So we have the rate of change allows you to see the relationship between two quantities that are changing. Okay? That's if I'm going up a certain way. If I'm doing a slope, most of the slopes we think of it's like when we're driving down a hill, they'll tell us it's a 6% grade. That is a slope to drivers. And also you will find slope, you'll hear about it when you are skiing. There are two types of slopes that are very, very, one that's very scary, and that's the slope that if you are looking at a coordinate graph, the slope goes straight up and down. Well, I hate to tell you that. If I was skiing and I saw a slope like that, that's telling me it's a cliff, and that is a very bad situation you're in, and I consider that the deadly slope. And that is called undefined. Undefined. Those are the slopes that are going straight up and down. And then you have what's called the really boring slopes on, if you're going cross-country skiing, they do the straight pathway, and that's just like same level the whole time. And that is a zero slope. And that's an undefined slope. So if you're going to crash into fall off of a cliff, that's undefined. You don't want it to happen, so it's undefined. And if you're going really slowly, you're just going at a flat surface in your skiing, that is a zero slope. So that isn't much fun either. So you have two really unfun. One is too dangerous, and the other one is very slow going. So the rate of change looks like this. It's a change in the dependent variable, so something depends on something else, over the independent variable. If you're looking at your coordinate plane up here at the top, the one that's going up and down, that is your y line. That is your y line. That is your dependent. That's your dependent line. The y line always depends on the x line. So that is the bottom part of it is your x. So the difference between on top would be your y, and the difference of your going from left to right is your x's. So another way of looking at it is the slope is the vertical change, so the up and down, to the horizontal change, which is left to right. Another way of looking at it is the rise over the run. Now, they also will give you what's called a coordinate points, and here's two coordinate points. So what you would do to find out the slope is I would put x1, y1 over the first set of coordinate points they give me, and then I would put x2, y2 over the second set of coordinate points. And then it says I would subtract the second y from the first y. I would subtract them. And then I would take the second x and subtract x1 from it. So that's how it would go. You would always do this set of numbers first, and this will always be the second. If you do it, switch them around wherever you want them to go, you're going to get a wrong answer. So if you can just keep it in this order, or if you want to, you could do all of these first and all of these second, but they have to stay in order. So let's try some stuff right now. Okay, on example 3, they give us the points. I don't have the, oh nope, they don't give you points. So what you're going to do is you're going to have to find points on your graphs where they meet on a graph at a whole point. So I'm going to say it meets here at a whole point, and it meets here at a whole point. Notice where they meet is where they meet at the vertical and the horizontal lines meeting together. Now, step 1, it was putting on the points. So step 1, put points on graph. G-R-A-P-H. That's step 1. Step 2. Start with left point and go up or down. That's a positive or negative depending on if you're going up or down. Depending on second point. So, if I take the first point, I'm going to make that purple. That's my first point. That is my most left point. And it tells me I'm going to go up because my second point is above the first point. So I'm going to go up. And I'm going to go up to the same horizontal line that the second one's on. So I went up 3, so I'm going to put it over here. I'm going to M equals. Slope is always an M. So M equals, and you'll see why on formulas in future lessons. So I'm going to go up 3, so I'm going to put a 3. Now, step 3. I'll put it right down here. You're either going to go to the left or right. Left is a negative, right is a positive. Well, you can't really go left, so you're going to go right to the second point. And right will always be positive. So I'm going to do that a different color so you can see it. It's going to be green. So starting where I ended my last arrow, I'm going to go over how many spots. So I have 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. So I went over 5. So M equals 3/5, and that's how you would do that one. I would like you to try, I will give you the points for B, where they're the most noticeable. That would be at 0, 3, and 4, 0. I'd like you to try to find out what the slope is on your own, and put me on pause, and then check and see if you got it correct. Okay, so from the left point, you went down 3 and went over right to 4 times, so it's negative 3/4. There's your answer right there. Now, example 4. This time you're going to use the equation that we discussed earlier, and I'll write that down again for you. M equals y2 minus y1 over x2 minus x1. So what I would do is I'm going to put x1, y1, x2, y2. Now I can plug those numbers into where they need to go. So on the top part of my fraction, I need to do y2 first, which is 7, and I need to put a subtraction sign, and y1 is 1. And then on the bottom, I have x2, which is 6, and I need to subtract it, and x1 is negative 2. Notice on that negative 2, I put a parenthesis. So I'm going to do 7 minus 1, which is 6, and then 6 minus negative 2. Well, these two right here are negatives, so we're going to make them positives. So 6 plus 2, which equals 8, and then reduce it, which is 3/4. Let's try it one more time with B. So M equals, subtract the top, the y's first. So this is x1, y1, x2, y2. So it's going to be 7 minus 5 over 4 minus 2. 7 minus 5 is 2. 4 minus 2 is 2. So 2 over 2 is 1. I'd like you to try C and D. D is going to be a little funky. Don't worry about if you cannot put like terms together. Just leave them the way they are. Try them out and see what you come up with. All right. So your answers for C would be negative 3/2. I'm not sure where the negative comes in, if it's on the top or the bottom, but the negative I like to put on top if you do. And D, notice it's all variables. It's D minus B over C minus A. Just leave it like that. That's how you would do variables. Most of us will not have variables on our homework tonight, to be exact. My class won't at all, but maybe some of you other kids who are watching might have variables. So that's how you would do that. Okay. State whether the slope is 0 or undefined. Remember when we went through it. If it's a slow slope and it's just slow and boring, it's just flat across when I'm skiing, it means it's a 0 slope. Now on B, I have a really dangerous slope. It's a cliff. So if it goes up and down, straight up and down, it's undefined. I wrote that down for you at the beginning of the lesson for you to know. Now, we're going to do the same lessons. I just want you to leave it in fraction form. So do what we did in example 2 with x1, y1, x2, y2 on C and D, and leave them in the form they are, and I'll come back to you in a second. Okay, so on C, I have 0 divided by 1. That is the fraction form of it. Now, if you have a 0 on top of a fraction, I know that 1 can go into 0 times. So my slope is 0. So that's what it would look like if I graphed them. Okay? Now, D. I subtracted 2 minus 1/2, and that's 1 1/2. And then I have 3 minus 3, which is 0. Now, I know for a fact, anything I multiply 0 by will never get you 1 1/2. So I know for a fact, this one is going to be undefined. If I graphed these, it would look something like this one. It would be a straight vertical line if I graph those. So that's the reason why that slope is undefined. Goodbye.